Surely the arm of the Lord is not too short to save, nor his ear too dull to hear. But your iniquities have separated you from your God. Your sins have hidden his face from you so that he will not hear. For your hands are stained with blood, your fingers with guilt. Your lips have spoken lies, and your tongue mutters wicked things. As it is written, there is no one righteous, not even one. There is no one who understands, no one who seeks God. All have turned away. They have together become worthless. There is no one who does good, not even one. Okay, everybody, look at 65. We're talking about radicals in trigonometric equations and how we're going to deal with those. Okay, so the first thing we're looking at this here. What can we do to get this in a situation that's going to help us? Would you suggest we use something like the squaring property? In other words, squaring both sides of an equation, except right now I have the radical is not by itself, so I can't do that. I need to get the radical all by itself before squaring both sides of the equation will help me. So let's get the radical on one side, and let's get the sine x on this side, and get the radical all by itself. Whoever's banging, please stop. All right, now I've got a radical by itself. And we've used this before, but we haven't used it with trig functions. So that's the new concept, Allie, is using this principle with trigonometric equations. Okay, so we're going to square both sides. And when we do that, we're going to get sine squared x equals, and then when we square that, we're going to get 1 minus sine squared x. So we've squared both sides of the equation, and now what's going to happen when we bring this one over? We're going to have sine 2 sine squared x, because they're both sine squared equals 1. Okay, and then we're going to have sine squared x equals 1/2. Okay, and then what will we do? What can we do at this point? We used the squaring property. Now can we use the square root property?
Yes.
Okay, so we can say, all right, well that means that sine of, this is sine squared, not 2x, this is sine squared x. So we can take the square root of both sides and get sine of x is 1/4. No, it's not 1/4, it's what? 1 over the square root of 2. Excuse me. Okay, so because I'm taking the square root of it. Now, square root of 2 on the bottom is not proper form, so that's the same thing as square root of 2 over 2. So I'm looking, and up here, this one was from 0 less than or equal to x is less than 2 pi. Okay, usually when we're in x, we're in our radians instead of in our degrees. So now I'm looking for, where is the sine of x going to be equal to the square root of 2 over 2? Where does that happen, Ben?
45 and 135.
Okay, 45 and 135, because you're looking for the sign being positive. Okay, so 45 and 135, okay, are your two solutions. Now, there's one reason why I need to check this. All right, remember when we were squaring both sides of any equation, we can take a potentially false statement and we can square both sides and we can make a true statement. Okay, so when we square both sides of an equation, we can get extra solutions. Okay, so since that squaring was in that process, and also, what did I forget to do down here? When I took the square root, I should have made that plus or minus, which makes that plus or minus, which makes this what?
225.
225 and 315, okay? Because now I've got the negative square root of 2 over 2, okay? So, because I did take a square root of both sides, I squared both sides first, I can come up with extra solutions. So I'm not sure that all of those are correct, okay? So what I'm going to do is I'm going to go back and I'm going to look and say, okay, if I am in over here, the sine of 45 is square root of 2 over 2, right? And then when I square root of 2 over 2, what is square root of 2 over 2 squared? I'm going to get 2/4 or 1/2, right?
Wait, is that plus or minus?
Where?
Yeah, no, down there.
This one,
plus,
yes.
Okay.
Plus or minus, because I took the square root of both sides, I should make one side plus or minus. So now, this one right here becomes a half. So 1 minus a half is a half, right? And the square root of a half is square root of 2 over 2 again. So square root of 2 over 2. So I've got square root of 2 over 2 minus square root of 2 over 2 is 0. Therefore, 45 works. Okay? Now, will 135 also work? Okay? The sign of 135 is still positive. Okay? So that part should be the same. The sign of 135 is still positive, so that should be the same. So this one should also work. Okay? So then I go over to 225, and I plug in 225. The sign of 225 is negative. But when I square it, it's positive. Okay? So in here, I'll still get the square root of 2 over 2, but over here, I'm going to get a negative square root of 2 over 2. So negative square root of 2 minus a square root of 2 over 2 is not going to be 0. And I can see that both of those are going to have to be crossed out because both of those make a negative here. This one will be a positive because it's squared and it won't work. Does everybody see how you can't always guarantee that all of those solutions are going to be true? Yes, Wes?
Okay, so you have sine of x is equal to negative 1 over square root of 2. How did you get square root of 2 over 2 out of that?
Okay, 1 over square root of 2, Wes. We multiply the top and the bottom by square root of 2 over 2.
Wow.
Square root of 2 over square root of 2.
Why would you do that?
Yeah.
Because it's negative?
No, it's because you have a radical on the bottom. You're not allowed to leave a radical on the bottom. Ben, could you plug me in and get my power is running out, huh? Thanks. Okay, everybody look over here at this other one, okay? And if you look on your book down at the bottom, you can see that 45 and 135 are the only solutions, and they went through that same process with you on page 417. Thank you. Okay, so now we're looking over here to another equation that involves radicals and trigonometric functions here, okay? So this one's already set equal to 0. So this one's pretty simple, okay? We're going to wind up saying what? Tangent x minus square root of 3 equals 0. Sine x plus 1 equals 0. Tangent x equals square root of 3. Sine x equals negative 1. Okay, so remember my little trick, I don't carry my tangents in my pocket. I know that tangent is sine of x over the cosine of x, and if it's square root of 3, I can take, I'm going to put a 1 on the bottom, square root of 3 over 1, and then I'm going to divide both of them by 2 to get functions that I recognize, like values that I recognize. I know where the sine is square root of 3 over 2. Where's the sine at square root of 3 over 2? That's a 60. And the cosine is also 1/2 at that same value. So this is 60. All right? So we're going to say the tangent, basically what you're doing is you're taking the arc tan of both sides, the arc whose tangent is. So the arc whose tangent is square root of 3 over 2 is 60 degrees. Does it happen anywhere else? Huh? 210? Is that the 60 in the... No, that's a 30.
Wait.
It's got to be the 60. Remember the 60 here.
240.
So the 60 down here would be, yeah, 240. 240. Okay? Yes, sir. Yes.
Thank you.
Okay, so then this one, where is the sign negative 1? 270. Only one spot, okay? Now, in that one, did we do anything that would have the potential of creating extra solutions? Was there any process that we went through that would have created the extra solutions? Okay, no, they're not there. So then look at the, yes,
why'd you divide both sides by 2 on the left square root of 3 over 2?
okay, this is just my little trick for putting them in sine and cosine instead of in tangents, because my little dyslexic brain doesn't carry tangents around. In fact, my brain carries very little around. Okay, I just rederive everything. And so basically, I put it in a form, square root of 3 over 1, so that when I came along and divided both sides by 2, it is in recognizable sine value. Okay, so I know that that angle is 60, and I know that it's also 240, and then the sine of x is -1 has to happen only at 270. Okay, so any questions on those? All right, everybody, look at the, now, on this one, this is a special note here. Look at this carefully, because we're talking about the whole equation, and we're talking about where something is undefined. Okay, if we were to plug in these values, and we plugged in a 60, and we took the tangent of 60 and we subtracted that, we would get, this one would go to 0. If we plugged in the 240, this one would go to 0, and we would solve our equation. However, we have to be